All right, welcome. Today, we are going to tackle one of the biggest, most fundamental forces in the entire universe, gravity. We all think we know what it is, right? But its true nature is, well, it's so much weirder and, frankly, more elegant than you'd ever guess. So let's jump in.
For centuries, this was the question. And on the surface, the answer seems pretty obvious, doesn't it? But the truth is, there's really no difference at all. Turns out the exact same invisible influence is running the show for both. And the quest to figure that out? Well, it sparked two of the greatest scientific revolutions in human history. So here's our roadmap for this explainer. We're going to start with that initial mystery, then look at how Newton came up with a powerful but ultimately incomplete formula. We'll see how Einstein's cosmic speed limit totally broke Newton's idea, and then we'll uncover gravity's true identity as the actual geometry of the universe, which leads us straight to its most mind-bending creation, black holes.
Okay, so our story kicks off with a really simple but totally profound observation that basically changed everything we thought we knew.
Before the 17th century, people thought the heavens and the earth were just two completely separate realms with totally different sets of rules. So the big aha moment was realizing that the force pulling things down here on the ground was the exact same force keeping the moon and planets in their paths. It was universal, a huge deal.
And the first person to actually put some hard math behind that universal force was, of course, the man himself, Sir Isaac Newton. For over 200 years, think about that, 2 centuries, Newton's law was the final word on gravity. I mean, it was precise, it was predictable, and it just worked flawlessly. But hidden deep inside all that success was a problem so fundamental it would take another genius just to spot it.
See, Newton gave us the what. He cooked up this incredible formula that could calculate the strength of gravity between any two objects with just stunning accuracy. It explained tides, it explained planetary orbits, the whole shebang. But it never ever explained the how. Like, how did the sun tell the Earth to stay in orbit across 93 million miles of pure, empty space?
This was the ghost in Newton's machine. His math implied that gravity's influence was instantaneous. If the sun just poof, vanished, his formula said the Earth would instantly know and go flying off into space. But how could any information travel that fast? Faster than anything? It just didn't make sense.
And that's where our new challenger walks on stage, a young patent clerk named Albert Einstein, who, funnily enough, wasn't studying gravity at all. He was studying light.
Through his work on special relativity, Einstein basically laid down a new, unbreakable law of the cosmos. There is a universal speed limit. Nothing, and I mean nothing, can travel faster than the speed of light in a vacuum. And this wasn't just for spaceships, it applied to everything, including information and influence. And that created a huge problem for Newton.
Okay, so let's really break this down with a thought experiment. In Newton's universe, if the sun suddenly blinked out of existence, the Earth would instantly feel it and fly off its path. But in Einstein's universe, that's impossible. See, it takes light about 8 minutes to get from the sun to us, so if the sun vanished, we wouldn't even know it for 8 minutes, and the Earth would keep orbiting that empty spot where the sun used to be for those same 8 minutes. You see the problem? Both of these theories couldn't possibly be right.
This contradiction just completely obsessed Einstein. He spent a full decade wrestling with this problem. He knew gravity had to obey the cosmic speed limit, but how? The answer he finally came up with wouldn't just be a little tweak to Newton's theory. It would completely tear down and rebuild our understanding of space, time, and reality itself.
So, what was Einstein's breakthrough? He realized that Newton wasn't wrong about the math, he was wrong about the entire concept. Gravity, it turns out, isn't a force at all.
To get his head around this, Einstein first had to fuse the 3 dimensions of space with the 1 dimension of time into this single 4-dimensional fabric he called space-time. And this fabric, it wasn't just some boring, passive backdrop for the universe. No, it was an active player in the whole cosmic drama.
And this is the big idea, right here. Gravity isn't some invisible, mysterious force reaching out across space and pulling on things. It is simply the curvature, the warping of the space-time fabric caused by mass and energy. Objects aren't being pulled, they're just following the straightest possible line through a universe that's curved. Okay, let's use the classic analogy. Picture a big, stretched-out rubber sheet. That's our flat space-time. Now plop a heavy bowling ball, that's our sun, right in the middle. The sheet immediately sags, right? It creates this deep curve.
Now, if you roll a little marble, our Earth, nearby, it doesn't get pulled towards the bowling ball. It just follows the curve in the sheet that the bowling ball made. And that path is its orbit. Gravity is the curve. Simple as that.
So, this new way of thinking about gravity leads to its most wild and extreme prediction. If a little mass curves space-time, what happens when you pack an absolutely insane amount of mass into a teeny, tiny space?
You get a black hole. It's a spot where the curvature of space-time becomes so intense, so extreme, that it basically rips a hole in the universe from which nothing can ever get out. The gravity is so strong that to escape, you'd have to go faster than the speed of light. And as we know, that's the ultimate cosmic no.
So how do you make one of these monsters? Well, they form when a really, truly massive star runs out of fuel and dies. Its core collapses under its own unbelievable weight, crushing a ridiculous amount of matter into an impossibly small point with nearly infinite density. A point we call a singularity.
And the effect this has on the fabric of space-time is, well, it's catastrophic. It's not just a gentle little dip anymore. A black hole creates a warp so deep, it's really more like a puncture, a bottomless pit in the very fabric of reality.
So there you have it. We went from a falling apple all the way to a literal hole in the universe. The journey to understand gravity showed us it wasn't a force at all, but the actual shape of the cosmos. And it kind of makes you wonder, right? If we got something as basic as gravity wrong for so long, what other parts of our reality are we looking at every day but not truly understanding at all?